rotor and stator, another example of streams becoming tributaries in the flow of production. The secret is to plan to ensure the accurate synchronization of components and sub-assemblies at the correct point along the line. Now the tray approaches the machined end shield stores, where it collects the end shields and passes on to the main assembly belt. The tray of components and sub-assemblies continue until they reach the operators, who now build the finished product. Hence, by the conveyor, they go for final testing and so pass out to the service in the world. Now let's go to the accumulator factory at New Malden, another of the Crompton Parkinson Group. Here, yet another example of this flow production technique is seen in the method by which batteries of many types and sizes are manufactured. Grids of antimonial lead have been cast and placed in packs on the main conveyor. Conveyor has also travelled through the paste mixing shop, collected the oxide paste, and together these components flow into the grid pasting shop, where the paste is inserted in the grids. On this machine, the grids are automatically pressure pasted at the rate of 1 every 5 seconds. The pasted grids, now called plates, inserted in plastic containers for convenient handling, proceed by roller path to the next process. A specially designed conveyor takes the containers of plates through a carefully timed sequence of seasoning and drying with automatic temperature and humidity control. And now, connector bars are burnt on, plate to plate. Another conveyor takes the plates to the formation department, where, immersed in acid, they are connected up and the plates are formed. Plate formation is the key to successful battery manufacture and is conducted with great care and precision. The plates are now loaded onto a conveyor which passes through a drying oven and on to the flow stores. This store may be likened to a reservoir of many types and sizes of plates that are feeding the main assembly. Here we have a new process for specially designed traction battery plates. It consists of encasing the plates in porous ebonite envelopes, and it furnishes another example of flow production technique in which many mechanical devices are used to save labor and speed up the flow. These roller paths include hydraulically raised sections which lift the trays of molds to the working level. These envelopes are formed by placing a porous ebonite separator on each side of the plate, separated from it by a layer of glass silk, and sealed round the edges by a strip of rubber which is subsequently vulcanized. This method of plate armoring withstands the arduous discharge conditions met with in traction duty. Passing inspection, the plates are then conveyed to the reservoir store, ready for issue to final assembly. At the stores, standard negative plates and armoured positive plates are placed on the conveyor running to the group assembly benches, where, under ventilating cowls, lead bridges are burnt onto plates to form a group. The negative and positive groups are married by being interleaved, and separators are placed between the plates. After the ceremony, the married plates proceed to a bench, where they are placed in ebonite cell boxes. The cell lids are inserted, ready for the next process. Now, on a moving belt, the cell lid is sealed with bituminous compound. And this done, the compound is flared to a smooth finish by means of a gas torch. And so the battery passes on to the next operation, burning on the connector bars. Cell vent plugs are screwed in, and are now through test and through inspection. They roll away for charging before packing for dispatch. Traction batteries are switched out of the line at this point, direct onto the container assembly section, later to be crated and dispatched. The commercial batteries have reached the charging section to receive the first charge. The batteries, now on stillages, are filled with electrolyte and connected to the charging panels, and finally inspected before dispatch. Perhaps the best example of all flow production technique is in the original F&A Parkinson Motor Works at Guiseley. Here, the science of production in the electrical industry was pioneered. Here it goes on being developed, and it is applied throughout the Crompton Parkinson group of factories. Its planning methods are duplicated in the overseas works in Australia, New Zealand, India, South Africa, and elsewhere. Watch these girls. Every movement, every convenience carefully studied. No waste time, no unnecessary labor. Note the light, airy and pleasant conditions in which they work. These things are as much a part of flow production technique as the engineer's skill and planning. So, in this coil winding department, you'll see as many hairdressing styles and pairs of silk stockings as in any fashionable West End restaurant. The working conditions are planned that way. The essential of flow production is component testing at frequent stages. Here, each stator assembly is being submitted to a high voltage flash test. The secret of reliability in all electric windings, particularly in electric motors, is the attention paid to the insulating compounds and the method of impregnation. Here, in a flow production layout, is a precise sequence of operations for this purpose. It is so engineered, there can be no mistakes. so far we've seen the machining of stators, the making of coils, the insertion of windings and the impregnation. Now let us take a look at the rotor, which begins its life as a machined shaft. Here we shall see a similar flow production technique to that used for stators. The final stage of rotor making is balancing. Every rotor goes to the dynamic balancers and is balanced to a precise specification. Meanwhile, the end shields are being machined on these automatic tools and then are finally inspected. And so the accessories all come together in trays, ready for assembly. This moving assembly conveyor shows the very wide variety of motors that can be made in a single plant by the flexibility of flow production technique. Here we see the beginning of the standard tests for electric motors. It's built to be quiet. In the inspection department, black is black and white is white. There are no shades of grey in testing. This, of course, is only the beginning, and there are many more tests to be made. The motor must pass every test absolutely, or it's rejected. Thanks to careful planning and thorough inspection, rejections seldom happen here. Perhaps now you realize that real efficiency in the manufacture of a wide variety of electrical products can only be achieved by flow production.
Whilst the world of today makes a ceaseless demand for large quantities of standardized electric equipment, it still demands many individual engineering jobs that are made to measure nature. The young engineers who work here, and the old ones too, have always some new and exciting job that demands their best energy and inspiration. Let us meet a young engineer who will tell us about 2 or 3 larger machines manufactured at Chelmsford. From his enthusiasm, you will gather that the pioneer spirit of Crumpton burns in these young men who find adventure and romance in developing electrical machinery for the world of today and